Hello guys, welcome back to Manala's Arc. So here's equations with fractions. Here's a topic called equations with fractions. This is a continuation from a series that I'm making for equations in grade 10. So before this video, there are two videos that I've created before. The previous one is about quadratic equation, and the one before that, it is about linear equations. So after every video, I leave some questions for you to solve. And for the previous video of quadratic equations, these are the questions I left for you to solve. So in case you didn't watch that, you can first try by solving these videos and solving these questions and see if you can win. And if you don't, just watch the whole video. I hope that's okay. So now here, I want to solve these three easy questions. I'm joking, they're not easy. They're just long questions. You just need to understand the basics and then you'll win with that. So let's get straight to it and not waste time. First question, here it is. So here basically what I need you to do. What I need you to do is that you need to express everything in terms of its denominators. So here you're going to have 10 over 1 plus 16 over x, it's equals to 4 into x plus 4 all over x. Now that you have that, what you want to do is to tell us your restrictions. So now in this case, when we talk about the restrictions, is that you're telling us that, okay, you can see that this is a fraction. And then if they want you to find solutions to these fractions or the value for x in this equation, there is one thing that must not happen. You see this denominator here, denominator x. If this denominator ever becomes 0, then it means this fraction is not a real number. And for this equation to be a real equation, it needs to have real numbers only, not imaginary numbers. So we are saying now x in this case is not supposed to be 0. Makes sense, because if x is 0, the equation is not real. Now we can solve for x. So the first step to do here is that you want to look for the LCM. What is your LCM? An LCM is a number whereby all the denominators can divide into, like x. You see x, 1 can go into x can go into x. So this denominator can go into our LCM, this denominator can go into our LCM, and this denominator can go into our LCM. Good. Once you've accomplished that, now you'll multiply every term or every fraction with the numerator LCM. So here you have 10 over 1. Multiply that with the LCM. It's going to be multiplied by x over 1. Do you see that? Then you move on to this fraction. You have plus 16 over x. Multiply that with the LCM. It's going to be multiplied by x over 1. Hope that makes sense. Then you have an equal sign. You write your equal sign. You move on now to this fraction, which is 4 into x plus 4 all over x. Multiply that with the numerator LCM, like that. So guys, please bear with me. There's a high chance that I will make a mistake in this video, making the whole answer to be wrong. That is possible. That is possible. So please bear with me. If I ever realize that mistake, I'll call myself upon it. I'll tell you that, you know what, yes, I've found the answer, but here on this step I made a mistake, so therefore it means it changes the whole thing. But if I don't, I know you will. Please bear with me. Bear with me. Okay. So, okay, let's move on. Now, here in this part now. Okay. Before I do that, this x numerator will cancel with the x denominator. This x numerator will cancel with the x denominator, which is the whole point. The reason we are multiplying with the LCM is because we want to eliminate all denominators. So once you get to a point where you've eliminated all denominators, you are almost there. So now here we no longer have a denominator. 1 times 1 is just 1, and everything divided by 1 is the number itself. So now here, 10 times x, that is 10x, plus you have you have 16 multiplied by nothing there, so it remains to be 16. And then here you no longer have anything except this numerator here. So let's write that numerator. Let's write that numerator here. So here you have 4 into x plus 4 this way. Then you continue solving here. You have 10x plus 16 is equals to 4x plus 16. Right, you know how to distribute, right? 4 times x, that's 4x, and 4 times 4, that is 16. All set. Now we send all variables to one side. But then look at this. We have 16 this side, and we have positive 16 this side, which means these two things cancel one another. We are left with what? Let's use a proper color here. Forget that. We are left with what? 10x is equals to 4x. What happens there? You transpose anything that has a variable to one side. So you have 10x now minus 4x, it's equals to 0. What happens there? You have 6x, it's equals to 0. You solve for x, you divide both sides by 6. Therefore, 6 and 6 cancels out. You are left with x, it's equals to 0. Now, look at that. Look at that. Our restrictions specifically said our x is not supposed to be 0. And we end up with an answer that says x is equals to 0. So we cancel the equal sign to show the examiner that we know that even though the only answer we got here is 0, that shouldn't be our answer. Make sense? So therefore we say here, therefore let me write it here in this box, our conclusion, which will be something you write below this answer here. Therefore the equation has no solution. What a beautiful way to start a video, guys. You start with a question that actually has no answer. So now in maths it shows. In maths, having an answer, it's also an answer. You did all these steps just to show us that this equation has no answer, and therefore that's your answer. Hope it makes sense. Let's move on to the next one. Now, next question here, we have this one. It looks challenging, it looks threatening, but actually it's not. You stick to the basics. So, before we mention our restrictions here, we first need to factorize anything that's factorizable. So I have 4 all over x minus 5. There's nothing to factorize there. When there's nothing to factorize, you put the binomials in brackets. Every time you see a binomial or a trinomial or anything that is not a monomial, put it in brackets or factorize it. So minus 10 all over x, no need for brackets there. It's equals to 2, and then this is factorizable. How? You take out a common factor x. Then you're left with x minus 5 there. Makes sense? Perfect. And then you move on now to your restrictions. Now, restrictions, we are saying x shouldn't be anything that makes the fraction unreal or anything that makes the denominator 0. So now in this case, x shouldn't be 0. So we are going to say x is not equals to 0. What else? In this bracket now, for this denominator to become 0, x should be positive 5. So it means now x shouldn't be positive 5 to avoid us having a 0 denominator. So x shouldn't be positive 5. See that? Same thing applies to this bracket here. X should not be positive 5. All set? Good. Now we move on to our our LCM. Our LCM now, it's us representing every denominator then. Choosing an LCM that every denominator that we have can divide into. Now, how do we do that? Let's start with the simple one. Where am I? Where is it? Right here. See this denominator of x. It's the simplest one. To choose a factor that x can go into without leaving a remainder, it's easy. That is x. Right? And then, but that is not the only denominator we will have. I mean, it doesn't make sense. It wouldn't make sense. Why? Because x minus 5 cannot divide into this. Right? So which means we have to represent x minus 5 now. So we're going to say x minus 5. You see that? So now what happens? Now what we see is that this denominator, it can fit in here. Perfect. And this denominator, it can fit in here. It can divide into this x. So that is perfect. And x plus x into x minus 5 can divide into x minus 5. Perfect. That's all that we wanted. Now that we found the LCM, now we multiply every fraction with the LCM. So I have 4 all over x minus 5. I multiply this with the numerator LCM. So multiply this with x into x minus 5 all over 1. Remember, whenever you have a binomial, it needs to be in bracket. Then we move on to the next part. Negative 10 all over x. What happens to that? We also multiply with the LCM. Multiply with x into x minus 5 all over 1. See that? Moving on to the next part now. The equal sign and the 2 into x minus 5. Right, what do we do that? We multiply this also with the LCM. Hope that's visible, and I hope it makes sense. So now once we have something like that, this x will cancel with the denominator x. The x plus 5 will cancel with the x minus 5. X minus 5 will cancel with x minus 5. And in this part, the numerator x will cancel with the denominator x only. And in this part, the x minus 5 will cancel with the x minus 5. What am I left with? I no longer have denominators anyway. So I'm left with 4 multiplied by x. How much is that? That is 4x. And I'm left with the negative 10 here multiplied with this binomial. Let me write it like that so I don't make any mistakes. Negative 10 multiplied by x minus 5. It's equals to, here what am I left with? I'm only left with a 2. So I'll put a 2 there. Make sense? Now I distribute the negative 10 into the brackets. So I have 4x into 4x, and then I have negative 10 times x, that's negative 10x, and then negative 10 times that, that's positive 50, that is equals to 2. How do we move on? These two things are like terms. I add them together, I get what? Negative 6x is equals to 2 transpose 50 to another side, that's minus 50. Then I have negative 6x being equals to negative 48. Make sense? I divide this part by negative 6 and divide this part by negative 6. Therefore, my x is equals to positive 8. Is that fair? So the positive 8 now, does it violate our restrictions? No. X being positive 8 doesn't violate this restriction or this restrictions. So we are all set there. Everything is perfect with us. Hope that's proper. Now let's move on to the next one. I don't want to make this video short. I know I talk too much sometimes. So here's this part here. Now this is the part that you want to leave last in your exam. Or if you feel like you have the strength now, the highest focus, you won't make any mistakes, then you will take this question. This question would usually, if ever I was the examiner for you guys, I would throw 8 marks into this question, because this is the worst ever you can get, I think. Okay, or let me say this was the worst I could pick up for me when it comes to equations with fractions. Not because it's difficult, no, because it has a long step, and the problem with long steps is that they can easily lead you into making mistakes. Let's see what we can do here. So first things first, before you give me your restrictions, I need you to factorize what's factorizable and put binomials in brackets. So we have 2x, it's equals to, I have my x minus 3, like that, plus, here I have my 5x minus 3, and then I have, look at that, this is factorizable, so I'll try to factorize that. I have a positive and a negative because this is difference of 2 squares. So I have a 3 as the first term, and a 3, I have an x and an x. This is equals to x all over x plus 3. Is this factorizable? No, but it's a binomial. I'll put it in brackets. All right. We're not done. We're not done. We don't determine restrictions yet. This is the funny part. We don't determine restrictions yet. We want to see now which brackets are the same and which brackets look the same, but they are not, but they can be made to be the same. It probably doesn't make sense, but it will soon. So now look at this bracket. I have a x plus 3. And here I have an x plus 3. Right? I have a 3 plus x. And then here I have an x plus 3. So these two brackets are the same anyway, because 3 is positive here and 3 is positive here. X is positive here and x is positive here. So these two brackets are the same. Make sense? So let me highlight them this way so I can always remember that these two brackets are the same. All set? Now I move on to the next ones now. So here I have this bracket x minus 3, and here I have 3 minus x. These two brackets are not the same. Why? Because x is negative here and x is positive here. 3 is positive here and 3 is negative here. So I must find a way to amend them in a way that I can make them to be the same. However, I cannot touch this bracket. Why? Because this bracket is attached to this blue highlighted bracket. So now, if ever I touch anything here, it affects the other one, and that's a whole complicated thing now. So I need to touch an independent alone bracket, right? So which is this one here? Because I want to fix this bracket and this one. However, I cannot touch this one, so it means I should touch this one. Makes sense? So now here I have 2x all over. How can I make the x negative and the 3 positive? I should take out a common factor. Which common factor now? Negative 1. Can take out negative 1 as a common factor. That will mean what? That will mean now my 3 is positive and my x is negative. Makes sense? Good. Plus, because I said this highlighted bracket is the same as this highlighted bracket, how about I write them the same way? I'll do that just now. So 5x minus 3 there. So to make these brackets to be the same, I'm going to represent them with x plus 3, because I already said they are the same. And here I have a 3 minus x. That is equals to x all over x plus 3. Don't forget to put brackets on binomials. Now that I have that, brackets that are the same and all that, I can go to my restrictions. What's not supposed to be true? So you see that you don't determine your restrictions in the beginning of the question. No, look at what's factorizable and what can be made to be the same as the other, and then from that point there you can give me restrictions. So here now, what will make this guy to have 0 as the denominator? It's x being negative 3, so which means I must avoid that. X should not be negative 3. We need to see these restrictions in your exam, by the way. I'm just writing them up here because I know I am going to erase at some point here, and I'll need to remember these restrictions. But the most logical thing to do for you is to write your restrictions on the next step here, right? And what else is x not supposed to be? If x becomes a positive 3 here, it will be 3 minus 3, and that will make the denominator 0. So x shouldn't be a positive 3. Oh, cancel the equal sign. X shouldn't be a positive 3. Same thing applies here. X shouldn't be a negative 3, but I already wrote that. And same thing applies here. X shouldn't be a positive 3, but I already wrote that. So those are my restrictions, right? And then from here now, we are looking for the, what? Say it with me. LCM. The LCM. The LCM merely means here that every bracket should be represented. Or we should write something whereby a denominator can divide into. Right? So look at this bracket of 3 minus x. What can 3 minus x go into? I mean, it can go into 3 minus x, right? So now, can the bracket of x plus 3 go into 3 minus x? No, those two things are not the same. So I must represent the bracket of 3 plus x also on my LCM. Does that make sense? So this part of the denominator is represented and this part is represented. How about 3 minus x? Is it represented? Yes, I already wrote that on my LCM. How about this denominator, the x plus 3, the one on the right? Is it represented? Yes, I already wrote that on my LCM. I don't need to write something twice in this case. Is that proper? Good. Now the next part is that I'm going to multiply every fraction with the LCM. So let's do that. So I have 2x into -1 into 3 minus x. Multiply that with the LCM. My LCM is 3 minus x and x plus 3. Moving on to the next part, this fraction right here, I have 5x minus 3 all into x plus 3 and 3 minus x, sorry. You see, I told you about making mistakes. It's so easy to make mistakes in complicated problems like this one or in fractions like this ones. Oh, this is a problem. Oops, we've hit a problem, guys. We've hit a problem. Oh dear. My system just crashed and some of the things were erased there. So what I'll do, I'll try to get back to the steps that I was on and see if I'll remember that. So let me try to quickly write and get to the part that we were on, I think, and then we'll take it on from there. Sorry for that. So yeah, I tried to pause the video and write all the steps that we had so far. I think we were somewhere here. Let's not let anything demotivate us, guys. Oops, another mistake. So here we are. Now what happens there? From here we multiply every fraction with the LCM. So this part, oops, another mistake. What's happening? Am I tired? No ways, it shouldn't be. We have this denominator here, this one. Remember the part that we are using now to multiply with the LCM? It's this last part that we had. This is the part that we are multiplying with the LCM. So multiply this with the LCM. Our LCM is 3 minus x and x plus 3 right there over 1. And then we have this part here, which is plus 5x minus 3 all over x plus 3 and x minus 3. We multiply this part with the LCM. Now it's going to make our fraction overlap now. So we have 3 minus x and x plus 3 all over 1. And then our equal sign, we need that. So here's the equal sign. I'll put the equal sign here due to lack of space. I was supposed to move to the right side there to Krillin. So we have x all over x plus 3, that's a binomial in bracket. Multiply that with the LCM. All over 1 right there. So and then from here I'll need some space, guys. Let me clear some things there and provide some space. So here it is. I created some space there. And then we move to the part of cancelling now. So we are saying the 3 minus x bracket cancels with the 3 minus x. And these two brackets will cancel with the whole LCM. The x plus 3 and the x plus 3 brackets will also cancel out. And there is one thing that we need to pay attention 2, that we don't make a mistake. So as much as everything else doesn't have a denominator here the 2x is divided by negative. So which means here we are going to have negative 2x, right? Multiplying with this bracket here, and that is x plus 3, right? Then plus, here I'm only left with this part, which is 5x minus 3. Hope that's visible. And the equal sign here is equals to x times this bracket, which is 3 minus x there, right? Then we distribute the negative 2 into the binomial bracket. Here we're going to have negative 2x squared and negative 6x plus 5x minus 3, that is equals to, distributing there, I'll have 3x minus x squared. Hope that's visible. So now what do I have here? I have negative 2x squared. This one and this one, they are like terms, and they give me negative x. Minus 3 is equals to 3x minus x squared, right? So now when I take this to the other side, when I take this here, I'll end up having negative 2x squared plus x squared, and then I have negative x. I transpose this to another side, it becomes negative 3x. Sorry. And choose a pen. Yeah. And I have the negative 3 there. That is equals to 0. Hope I didn't make any mistakes. So, and then here I'll end up with negative x squared minus x. Oh, sorry. Negative x minus x, that is 4x. So, negative 4x minus 3 is equals to 0. Hope that makes sense. Then let me create some space again. Boom. Wait. As I was moving things here, I forgot my restrictions. My restrictions were before my laptop crashed. X is not supposed to be equals to negative 3. And x is not supposed to be equals to positive 3. Those are my restrictions. Hope you still remember those. Let me save this so it doesn't crash again. So it's saved. We are safe from crashing. And then boom. Let's remove this. Let's create some space. Right, that's all we need. So we are saying we have x squared minus 4x minus 3, that is equals to 0. We divide every part by negative 1 because we need x squared to have a positive exponent. Those are the basics for a quadrinomial. I hope you see that this is a quadrinomial now. So and then we have x squared. This changes the sign, it becomes positive 4x. This changes the sign, it becomes positive 3, and that is equals to 0. And then this is factorizable as a quadrinomial. So I open two brackets. That is equals to 0. I hope you watched my previous video and you are able to do this based on my previous video. So now the last term is positive, which means our signs will have the same brackets. The brackets will have the same signs. And then we have an x there and an x there as factors of x squared. Factors of 3, we have 3 and 1, and they do add up to that, right? And then here, what are we left with? Let me see. Let's erase that. We don't need to erase everything. We are done now. Perfect. So the zero factor law, we are saying this bracket, we equate it to 0, or we take this bracket, we equate it to 0. Therefore, our x, it says it's equals to negative 3, or our x is equals to positive 1. But according to our restrictions, remember restrictions, we said our x shouldn't be negative 3 and it shouldn't be 3. So this negative 3 here, we put a cancellation. because we gave a restriction. Therefore, it means our x is equals to positive 1. See how easy is that? And that brings the end of this problematic question. I couldn't even believe that I was even going to finish this video because my laptop crashed like 4 times. Some of the moments you didn't see them because I was pausing the video, clearing the screen to provide some space for more steps to write there, but it was not possible. Like, it kept on crashing. This was one of the most problematic videos I had to do. A simple 30-minute video, it probably took me more than an hour, but those are the problems you'll get to see obviously when you're creating videos, right, guys? So not much complaints there. Let me give you things to do, some few questions to do on your own and see if you understand, because what's the purpose of watching a maths video if you're not doing any maths yourself, right? Let me give you those questions now. So here are the questions. Please attempt them and see if you can solve all of them. I know my handwriting is somehow, but please try as best as you can. The first one should be doable. The first one should be easy. Second one doable. Third one difficult. But I'm hoping that you win on all of them. That's all that I want from you. That's all that I'm asking from you. You need to pace yourself when you practice these questions, guys, because there's not enough time in the exam. So you need to learn how to pace yourself. Don't spend more than 5 minutes on any of them. So all of them, as you solve them, make sure you spend less than 5 minutes in each question for this one specifically. So thank you for watching, guys. I hope you enjoyed. It was a very terrible video for me to make this one because my laptop kept on crashing many times, but the end goal was for me to finish this video, and finally I did. And thank you again for watching. Please don't forget to like and share the video with others, and if you haven't subscribed, please do. And I hope to see you on the next one. The next one is about simultaneous equations, so I definitely hope to see you there. Thank you.